All right, just a quick introduction to exercise 9. We're going to be looking at modular sizing, something that you're going to hear a lot about over the next several months and maybe a couple years. And what we're talking about is the standard size that lumber and panels basically are sold in. So when you think about you want to go buy a sheet of plywood or OSB, you're typically going to get that in a standard size panel, which is 4 feet by 8 feet. When you purchase lumber, it's usually going to be sold in 2-foot increments. So you can buy a 2x4 that's 8 feet long, 10 feet long, 12, 14, etc. And so the closer we get in our design to conforming to those modular sizes, the less material we waste, the less time we waste on construction, because it does take longer to cut the wood and make it the size that we want. So we're saving on material, we're saving on labor costs, and ultimately we're just improving efficiency overall. So when possible, we want to design the perimeter of our building, and that's essentially what we're talking about, is just the outside boundary, the footprint of our building, using modular sizes. So we're going to kind of step through exactly how to do that here in just a minute. So that's what the introduction is talking about. I would encourage everybody to kind of read through that. Gives a couple examples of sizes that are not modular, like 12 foot 3, 13 foot 7.5, etc. Here is a list. Let's kind of take a look at this modular size list priority. Ideally, our modular sizes, and again, we're talking about the segments of the house around the perimeter. If you're looking at it in plan view, how long is each leg of the house? We're talking about like a 12 foot or a 14 foot or a 16 foot. So an even whole foot increment is the best. That's ideal. That's our goal. When that's not possible, sometimes we have to compromise. We don't need that whole feet. So we can cut it down to a whole even and odd foot increment. So 11, 12, 13, etc. Half feet, in rare cases, we might have to go 11 foot 6, 12 foot 0, 12 foot 6, etc. Just kind of round it to the nearest 6 inches, but in no circumstance almost would we ever sort of go into a smaller increment than that. So non-modular size, 12 foot 3, 13 foot 7.5, there's no reason to have one of those segments around the perimeter of our house to that precise of a location. You're almost guaranteed to waste a lot of material when you do that. All right, so let's kind of take a look at the instruction part. We're going to create a new drawing using the normal architectural template. We'll give it a name, and then we're going to take a look at the image on the next page. So using the estimated room size is shown, and let's just kind of take a peek at this. We're going to try to estimate each one of these perimeter lengths around the outside of this house, and once we kind of get that figured out, we're going to actually draw that perimeter wall. So you're going to kind of go through the process I'm going to demonstrate here in just a minute on calculating each leg of that perimeter, and then you're going to come up with your best guess as to what that ought to be based on trying to replicate this. We'll call this a napkin sketch. Okay, so we'll pause there on the instructions. Let's go ahead and just take a look at an example of this. This is not the house that you're going to be doing. It's a different one, but I want to step through the process with everybody and just make sure that everybody kind of understands what's going on. So what we're actually talking about is whenever we're drawing a floor plan, we usually start with that outer boundary. And we're not talking about just the wall, but like the outer part of the wall. Again, we're talking about the framing. And so we're going to figure out what the length of each of these line segments ought to be, and then we're going to draw that in AutoCAD. So let's kind of start at the back of the house here. The way this works is we just kind of we're often given sort of approximate room sizes. Now, if we're not handed room sizes, at some point during the programming, we're going to have to come up with a room size, right? A targeted size for the room is an important thing to know whenever we're going to design a house. Even if we're designing it from scratch, we're going to at least want to know, okay, we're going to do a great room. So how wide and how long do we want that thing? And there's going to be a range, right? But we want to make sure that we accommodate that size, whatever it is. We don't want to end up too small or too big. Too small means that client's unhappy, don't have enough room for their stuff. Too big means we've sort of wasted some of their money, right, unnecessarily. So let's go ahead and take a look at this. Let's figure out the back of this wall right here. What should it be from corner to corner? Again, we want it to be an even modular size if possible. If not, a whole foot odd modular size if necessary. And then in a very rare circumstance, we might do something foot 6, but never a smaller increment than that. All right, so the width of this great room is 16 foot 6. The width of the master bedroom is 12 foot 2. And so we can assume that that's the inside measurement of those spaces. So we would add those two numbers together, plus 5.5 for this wall, 5.5 inches for this wall, and 3.5 inches for this wall, assuming those are 2x6 on the outside and 2x4 in the middle. We take all those numbers and we add them together, and if you do this yourself, what you'll probably get is 29 feet, 7.5 inches. Okay, that's not a modular size, but we do know that without a whole lot of additional length being added to that 29, 7.5, we could come up with a nice even 30 feet, which makes perfect sense to do a sort of a major portion of this house, nice and modular, 30 feet from corner to corner. So I would just sort of either print this out and jot that down, or just sketch this on another piece of paper and write that down, and then I can move on to my next leg. So the direction that you progress around the perimeter really doesn't matter. I'm going to just kind of continue on with this major length right here along the right side of the house, and that one's going to be a little bit trickier than the last one we did. There's a whole lot more rooms that we have to calculate. There's some rooms that are not clear how big they are, so we're going to have to estimate. And then there are some things that we can draw from our knowledge about the standard sizes of things, like the depth of a closet, that we can put to work for us in figuring out the rest of the puzzle. And that's really what this is. It's a puzzle, and it's not set in stone. We can always, as we start to lay out the interior of the space, if we find that we just don't have enough room in one area or another, or if we end up with too much room, for example, we can always use our stretch command, right, in AutoCAD to adjust the size of that room, and we can do it in a specific way so that the length of that line segment out on the outside remains modular. So as we can see, the master, if we start up here, we're trying to figure out the length of this wall, right? The length from the inside north to south in the master looks like it's 16.2, so we can jot that down. Next up, we need to get down to this wall right here, and there's nothing in this bathroom that indicates size. However, if we had something else here that we knew the length of the tub, we could sort of estimate the size of this bathroom. But I think another strategy, we could come over here because there is a size on the walk-in closet. So we can estimate this distance right here from this wall to this wall, and then we can estimate this distance right here for this little hallway right here. And I would have to guess that this is probably about 3 feet, this is probably about 4 feet. If you compare the size of those two things against each other. Now we're leaving aside the thickness of the walls. We'll do that at the end. We're just trying to find the interior spaces. We're just going to stack them all together until we get down to the bottom here. So if this is 3 and this is 4, we could sort of add 7 feet to our list. And then for this one, north to south, it's 6'8", so we'd add that. And now we're down to this wall right here, so we're going to drop all the way down to this wall by adding this 11'2" for the vertical size of this bedroom. And now we have to sort of employ some of the knowledge that we've gained. We know that a standard bedroom closet is about 2 feet deep. So we can add 2 feet for each of these closets. That's 4 more. And then down here at the bottom, we add 12. So the next thing we can do is add up the thicknesses of all of our walls. So we would have a 5.5 thickness here, a 3.5 here, a 3.5 here, 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 and here. So we've got, what, 6 3.5s, and then we have 2 5.5s, one at each end for this exterior wall. So if we take all those numbers and we add them up, keeping in mind, of course, that we estimated some of that stuff, I actually came up with 59 foot 11.5 inches. Well, that worked out pretty well. I would say we round that thing up to 60 and call it a day. Let's keep going. We'll round the corner here. We're looking at bedroom 3, the width from corner to corner on this leg right here, and it says that the bedroom is 12 feet 0 inches across. Assuming that's the inside, it's going to be pretty close to 13 across on the outside. So 13 definitely is a modular size. It's in the second level of the priority tier that you saw on the instructions, but it certainly is going to work. So we'll go ahead and accept that 13 right there. If you didn't mind your bedroom only being 11 and across, you could certainly make that a 12 instead, but that just kind of falls under what we might call the designer's artistic leeway. You'd also maybe check with the client if you're working with somebody. But getting this right in the beginning is really essential. Just making sure that we're keeping it modular, but also ensuring that we're achieving the design intent. In other words, whoever we're working with, we're giving them what they want and what they need. Okay, so we've got 13 feet across here. You can sort of guesstimate that this leg and this leg are pretty close to the same. You could even, if you wanted to, grab a piece of paper and mark it and then move it over here and just kind of see how those things compare. Is this more or less? But I'm going to kind of use my own judgment and say that this one is maybe just a little bit shorter than this one right here. And so I'm going to go with 12 to right here. For the wall gap across the covered porch or across the foyer area, you could sort of approach that by just looking at, okay, well, how big of a bench do I want? But really, the things that are driving this width right here are the bedroom size, the bathroom size, how wide the entry foyer is, and then also how wide the laundry room needs to be to fit a washer and dryer in there. So that's really what you need to pay attention to most is, do I have enough space for all the things I need to get in there? Rather than right here just estimating what that needs to be, look instead at the things that have to fit. If you make the laundry room too small, you're not going to get a washer and dryer in there, and that's a problem. So sometimes a little research is called for with a washer and dryer set. A lot of times the designed size for a washer and dryer is going to be 30 inches each, so you might have a 5-foot gap in there. But you're probably going to want to go a little bit bigger than that, and doing a little research by just checking some of the modern washers and dryers that are available. Since this would be new construction, we want to make sure that the latest, greatest stuff that's out there on the market is going to fit. So you might just add a foot in there. So if we come across here, we can say that this is maybe 5.5 feet. We could say that this is certainly bigger, so you have at least 6 feet probably across this foyer, I would say. This bathroom also looks like about 6 feet wide if you just kind of compare the two. Also, we know most standard tubs are 5 feet long, and you also have what looks like maybe about a foot deep pantry right here. So we kind of got to think about the overall size, fitting those things in there, and then while we're also having to accommodate an 11-foot wide bedroom. So when I add all that stuff up across here, and I add the thickness for this wall, this wall, this wall, and remember I got to do the outside of this wall because we're going to have to subtract it from what the width of this bedroom is, which is 13, we said. I end up with 29 foot 10 from the outside of this wall to the inside of this one, which is where we're headed, right? That's the perimeter here. 2910 is a pretty nice round number. We subtract from that our 13 to get this total distance here. We end up with 1610 across here. Well, that's an easy one to round up. We're just going to call it 17. There's really not a great way to guesstimate this leg right here. There's nothing in the room that would indicate, how big that is. You could certainly take this garage size and subtract these things right here. It'd still be an estimate. I'm going to eyeball this with the idea that when I'm all done, and once I get this wall set in place, I can certainly stretch the front of this garage larger or smaller if I need to, pretty easily. There's not a lot going on in that area. I'm going to start with 8 feet because I know a standard garage door is typically going to be either 7 or 8 feet tall, and I'm seeing this one just kind of eyeballing it. It's looking to me like it's an 8-footer. I don't know why. So I'm going to say 8 feet from this corner down to this one. This next leg should be super easy. It's saying 21 feet side to side in this garage. I'm going to just call it 22 corner to corner. For this left side, I'm going to ignore for the moment this awesome outdoor barbecue nook, and I'm just going to kind of round the corner and assume this is the edge of my building. We could always add that on, and the size really isn't dependent on much else other than it lining up with this dining room here. So let's just go ahead and say we're going to go to this back wall right here. Down to this corner, we're going to add our 22.6 and our 17 feet, which is presumably this little nook area right here. And when I add in the thicknesses of the two end walls on this segment, I end up with 40 foot 5. Okay, so now I have a choice to make. Do I want to go larger or smaller? Because I don't want to leave it at 40 foot 5. I could round it up to 40 foot 6, and technically I would be within modular sizes, but there's not a real good compelling reason to give them that 6-inch, and it is going to result in waste. So I would prefer to just round this one down to 40 feet or round it up to 41 or even 42 possibly, depending on if I want to increase or decrease the size of the garage. If it's my garage, I'm probably bumping that thing up from 22.6 to maybe 24.6 or something like that. So, or 24. So I would be tempted on this one to just extend this garage nose out a little bit farther, but we'll come back to that another time. So this leg right across here, we can look right here and see that it's 10 feet across inside to inside. We do need to go to the outside corner, so technically that would be closer to 10'6" if we did that, but I think I'm going to use my own judgment on that and just downsize that to 10 feet total on the outside. Your judgment may be different, and that's okay as long as it's modular. I'm going to call this leg 8 feet, and the reason I'm doing that is I'm just sort of eyeballing it and looking at that segment, and it's looking very similar to the length of this wall right here, and also 8 foot's a nice modular size, so we'll go with 8 feet there. So at this point we're essentially done. This segment right here is going to be just whatever's left over, because we've already got this segment figured out and we've got this segment figured out, and we've worked all the way across the front of the house. So we could come up with a number for this, but in reality what we ought to do is just close this loop in AutoCAD and then figure out make sure that that dining room is according to plan, is falling into that 11'6" interior dimension that it's provided. The same thing is true for this segment right here. We've already got the overall size and we've worked our way around all the way back to here. So that one, since we started in this corner, is just going to be a given as well. So now I've worked my way all the way around the perimeter. It's time to go back to the instructions and see what those have to say at the end. All right, so the next step, draw the exterior walls according to the modular sizes you came up with. We're going to omit for the moment any decks or porches or patios or anything like that. That's certainly something we can add on later, but the important piece of this is figuring out the house. You can use whatever drawing method you like. I prefer what we have talked about in the past, using P-line around the perimeter. That way we have a nice clean offset to the inside to set that exterior wall thickness, and we don't have to do a bunch of trimming. Once that's done, you of course can and should explode those walls so that we can use those individual lines to create the interior portions of the house. Note, you are not required to complete the whole floor plan, just the exterior walls. That's all we're doing on this, folks, so don't make it harder on yourself than you need to. We will be putting in doors and windows, and we'll be adding dimensions using proper exterior dimension techniques just to show what you came up with quickly and easily. No overriding your dimensions on this. Your dimensions are intended to tell on you if you miss on a modular size. Fix the geometry, don't change the dimension. That's true really across the board. That's just a rule. You never want to override a dimension, never being obviously a qualifiable word. We never say never or always, but generally that's just not something we do. If you feel pretty good about your process that you use in AutoCAD, you feel free to drop off this last part of the discussion. I'm not going to force anybody to watch it. Just keep in mind that you might learn something, so it's only going to take a minute to kind of go around and show you my technique for this. You might learn something in this that helps you just kind of get this done a little bit quicker. So here we go. Just keep in mind you're going to be submitting the PDF. You're going to generate a PDF by printing to the PDF writer, and then you'll also submit the CAD file. So we'll kind of step through both of those as well. So we're going to go ahead and start a new drawing. We're going to be using the architectural template, of course. And then we're just going to go around. I have my sketch in front of me. You can't see it, but my sketch in front of me, we're just going to kind of follow the same path that we did when we measured. And I'm going to be using P-line for this. So make sure that you kind of plan that out accordingly. I'm just going to pick my first point in space here. Click. I'm going to move my cursor off to the right and I've typed my first distance, 30 feet. Enter. Now I'm going to pull it in a downward direction. Remember that distance was 60 feet. Enter. It's just direct distance entry. This leg was 13 feet. All nice clean modular sizes. This one was 12 feet. This one I believe, yep, 17 feet. 8 feet. 22 feet. 40 feet. 10, another 8, and now we're sort of at that point where we just need to close everything up. So we're just going to pull this down using O-snap tracking, and then we'll close that P line like so. All right, I'm going to turn off the UCS icon, and then I'm going to offset this guy in 5.5 to the inside. And there it is. That's our perimeter. Now, I mentioned earlier we wanted to double check this width right here. Remember that our image was showing, I believe it was 10 across there. This is the wrong image. There it is. Oh, excuse me, 11.6. So this should probably, this leg right here, if I had to guess, should be about 12 feet. Let's see if we got that, if we are close on that. So I'm going to use my distance tool right here, and I'm just going to check from this corner to this corner right here, and look at that, 12 feet right on the nose. So sometimes things work out exactly the way that you want them to. Other times you might come in and go, oh geez, that's only 10 feet or something, so you might have to do a little bit of stretching and adjusting, finding that happy medium between the measurements that you came up with. As I mentioned, you will be dimensioning this. You should have had plenty of practice with that by now. And then we also are going to be setting it up on a sheet to print. And I have no idea what sheet size is going to fit at a 1/4 inch. So I'm just going to start with C. I'm going to see if we can get this thing located in there. You notice I activated the viewport. I double scroll wheel clicked inside to zoom to extents. And now I'm going to set the scale and see what happens. I'm going to go to a 1/4 inch. Try that first. And that one actually does fit. It's going to be a little snug with the dimensions on there, but I could expand that viewport out a little bit bigger. And so this particular house fits. I think the actual assignment house, the one you're going to be doing, is probably going to be a little bit different. Well, it's definitely going to be a different shape, and that one might fit on a C size sheet. Might have to go up to a D. It should say right in the instructions, I believe. So either way, the process is the same. You just might pick a different sheet to do it. So this is the house that you're going to be doing. So lots of little nooks and crannies, little corners that you'll have to figure out. But hopefully it makes sense. Hopefully everything that we've talked about in this video kind of works with the way that you normally would do something. But if not, certainly reach out and let me know, because this is an important skill to have, and it's one that you'll repeat in the future a number of times. That's it. I'll leave you with this thought. Make sure that you don't get tunnel vision when you're doing stuff like this. Take a step back and look at the overall shape. Look at the proportions in particular. Make sure that what you end up with side by side with the thing you started with, they look similar. If they're way off in any aspect, just doing the gut check, the eyeball routine, make sure that you go back and you double check your measurements. Make adjustments as you need to. All right, reach out with any questions you may have, and we'll see you all in class.